Hi everyone, welcome back. So a long time ago I made this one where the objective is given this visible workstations here, place one chair next to every desk in the same kind of orientation. It works like this. I select the chair and then I select the desk as the source. It will find all the desks in the view or in the project and place the same chair in the same kind of orientation. Um, the the way it works is that it will place this coordinate system for each of these elements, and using the source vector from the chair to the desk and replicate the same kind of vector um, in this new desk and this new orientation to determine the place of the desk, the place of the chair and the corresponding rotation of the chair. So this one is useful and with some limitations. And now we're going to do is we're going to apply the same logic and use it on tags. So as far as we know, if I want to tag all the desks in this view, I go select all the desks and tag all. This is a generic model element, so I go like that. And then it places the tag in the center of the element. Well, as far as readability goes, if I want to maybe shift it over here, and you see that it works over here, but not so much when the desk is at a different rotation. You always get these things that are obstruct the view. So apply the same logic. What we can do is this tag format painter. That's the thing we're going to show today. I can come here and create a source tag in the way I want it to do and go run. What it will do is we're going to ask me to select one tag as the source. I'm going to pick this as the source and then select elements to be tagged. I'm just going to select everything over here. Go finish, create tag on active view, and then voila. These tags are following the same kind of styles, even though in here, because tag always read horizontal, the leader comes a little bit wonky, but you get the ideas. Nothing is blocking the view. I can come here and tag another one. Let's say I want to tag the chair. And then let's say I want to move it over here. Run this again. All I need to do is reset the source. Pick this new tag and come here to say select everything to be tagged. Finish, create tags on active view. The chairs are not tagged. Outside the view, completely readable. I can run this again. Now because here it says readable current tag type, the data from the previous tag we created for the chairs is already stored. So I don't need to reset it if I want to tag again the chairs. I can just go ahead and select and done. It remembers the tag location and it also works on different scales. So that's a 1/16" scale and this one is a 1/8" scale. If I want to do this, basically it adjusts them according to scales. select all, tag active view. See, still pretty much the same location, although we could probably move it closer, but it is good enough. The current thing works for model tag and multi-category tag. So here I have one furniture, another furniture, and one generic model. If we want to multi-category tag it, say put it over here, and then in order to tag multi-category and tag not only this chair, what we're going to do is, oh, by the way, I'm still in tagging mode, so that's why this is still thinking. I need to jump out of tagging mode for it to work. Reset source and sorry, uncheck filter by element type. So now this is going to regardless of the element type that's going to be tagged. Now create tag on active view. See, things comes in a little bit weird. That is because this chair, if I want to create a new, see, is always pointing up. The default location is pointing up. But this chair, the default location is pointing towards us. That's why there's a difference. No matter, what we can do is still, let's just tag all these families and put in align this. All we have to do is tag them 3 times by checking the filter element type. Reset type, select. I can still finish this work relatively fast. Now all these chairs has been tagged and they're all pretty much aligned. So to sum up the workflow, what this is working is we select a source tag and we select a group of elements to be tagged. We use the source tag to extract tag data, the type of the tag, the locations, whether it has leaders or not, and then write that data to external files so it can be remembered across multiple runs. And using filter the input element, I mean filter by element type or family type or not, and then read the tag data from the external source, eventually create a tag and paint that format. So that's pretty much the workflow. Now let's talk a little bit deeper into what kind of data are we looking for. Obviously, there's the tag type, whether it's multi-category tag or not, whether the tag runs horizontal or vertical. Yes, if I want to reset it and have it run vertical, I can create tags that are always vertical. We're just not going to show that for now. And then the second tier obviously is the location for tag, whether it has leaders or not, the leaders are attached or free, where's the leader's end location, whether it has elbows or not, the leader's elbow location. So for example, if I'm going to do this so I'm going to create this look and then run. reset source, select all. Now we create these tags. If I open these, the external source, what we can read is that it's going to say the first is the tag type, and then this is a generic modal tag. These three are the location XYZ for the tag, whether it has leaders or not, free end or attached end, the end XYZ, whether it has elbows or not, and then the elbow XYZ. Finally, it's a horizontal tag. It's been tagging on a view that is 1/8 inch of scale. The family that is being tagged is a desk, and some other information that we're going to refer later on. So we have the locations, the owner view scale that is used for scaling the position of the tag across different view scales, and the host family type that we set, whether it's filtered by it is a desk or it is a chair or not. And finally, some other things we're going to refer later on. Now, it is the same logic. The essence is to place this XYZ in here, following the family's orientation, and draw the vector from the tag to the family, from the leader end to the family, and from the elbow to the family. But because these things are working on different views, there's a few things that are different from just placing the family, placing a point-based family around another point-based family model. For instance, in here, how about face-based element? So here we have a few, these are section views. These section views, we have a couple racks and couple patch panels hosted on the racks. We used this in the past scripts where I described creating, placing patch panels on racks based on Excel. These patch panels are face-based element, so here I have a wall. I can just rotate all these patch panels. Now, in this case, if I want to tag it, I have to multi-category tag. What I can do is something like this. Notice how these tags are hosted on a face, and when it is hosted on another face, it's also rotating. So that's two different types of rotating, where on the desk example, the XYZ of the desk is on this view plane, which is essentially the global XYZ. But when it's on the host face-based view, the XYZ of those patch panels are actually on this section plan, which is, if we're looking at here, the section plan is pointing not the global XYZ. So we get essentially two types of scenarios. When we're dealing with element using point as locations, there are two kind of views. where the element z vector is parallel to the view's normal or not. In both cases, here, the element z vector is pointing towards us, and the view normal is pointing towards us, so they are parallel. In this view, it's parallel, and in the desk view, it is parallel. It's the global z in this case. But let's say in here, we're looking at the section views for these desks. That's when it is not parallel. You see, like, the rotation angle for the desk, is pointing up. That's the z vector. So in this case, if we're going to tag it, we do not want the rotation of a family to affect our leader and tag look. In fact, if we try to tag it, we'll find that even though the desks are at different rotation, the tag in this view looks all the same. We can even move on to another view where they are at a different angle and try to tag this again. The leader style will also not change. That is because we're going to go in different ways in here. When the element rotation vector is parallel to the view normal, that means the element rotation matters to the tag's corresponding location. At that point, we're going to use the element internal coordination as the coordination to calculate the vector. So in this case, that's the element internal coordination. And we're using this as the vector to calculate the using this as the coordinate to calculate the vector towards the tag. The same goes for the face-based example. This is the element internal vector, in which case it will be like that, for example, for this one. And we're using that and the element location to calculate the vector. But in the section view, which the element's rotation vector is not parallel to the view, at that point we're going to use the view vector, which is essentially the view x, y, z, which would be, let's see if we can find one. Yeah, not really. That's pretty much it. So the x, y, and z is pointing towards us like this. So we're using this as the vector to calculate the leader location for the tag so we're using this one instead of that one to calculate the leader's vector. Therefore, every one of them will be the same, even though in the global XYZ, the elements are at different orientations. But in this view, they're all using the view orientation as the coordinate. So when the element z is not parallel to view normal, using the view as coordinate system. When it is parallel to the view normal, using the element as coordinate. And that's enough for the point-based element. Let's talk about line-based element. In the previous examples, when we're placing model families, I didn't do when your element is a line-based. But for tagging, this is we cannot essentially avoid that. So, for example, this is a cable tray, and we're using the bottom hat tag as an example for here. Reset source, select elements to be tagged. As you will see, it works on line-based element too. It's not so much when the tag is the line is at different orientation. It looks a little bit weird, but it is working as long as all the trays are at the same angle. It works fine. For example, over here, if we want to go ahead and do the tagging, now in this view, every cable tray is horizontal. It will work fine and create these parallel tags for us. Now, when it comes to line-based element, the scenarios is a little bit more complicated because previously we're drawing a vector from the element to the tag, but when the element is a line, the location is a line, we do not know where to draw this vector by default. So we're going to first choose one point along the curve as the element location. And there is, again, two kind of scenarios, whether the curve is parallel to view normal or not. Simply, in this example, we'll see that there are cable trays going up, there are cable trays going horizontal, and then there are cable trays where their location, where the curve is parallel to our section view normal, meaning that they are just pointing towards us. So there's two kinds of cases where your tray is pointing towards us, or where the tray's projection on this section is a curve. We need to work in both cases. Like that. So this one is simple. When the projection on view is as a point, you can essentially treat that as a point-based element and simply use the view as coordination. The element's location is the projection point. Essentially, I'm drawing the vector from the projection intersection towards there. And that will be what we're using to replicate to find the location of the other tag. But when the projection is a curve, it's a little bit different. The approach I took is we're going to use the projections as coordination, the curve projection as coordination. Basically, if I bring in the xy, it will be for this one like that. And for this one, using the view direction as X, so it will be like that. Right, basically like that. And then I'm going to trim the projection by view curve region using the curve follow view X plus or Y plus, and eventually the element point is curve at a certain curve parameter. A little bit complex over here, but we're going to explain it in here. So the way it works is, for example, if my source is over here, you see, like at the end of this tray, I'm gonna select source element to be tagged 1, 2, 3, 4, 5. The newly created tag will also at roughly the end, meaning what I'm trying to do is use I have the source, and then the approach I took is from the source, draw a perpendicular line towards the element X, and use the essentially intersect of this tray and the normal projection line from the tag. This intersect is my element point, and the point will be at a certain in Dynamo is called point at parameter along the curve. I'm going to replicate this parameter and project that to the other trace. And then the vector will be from here to here. And then the same thing will apply to the other ones. If I open on the text files right now, you'll see that here in the very end it says 1.01. So essentially 1.02 because the perpendicular line is longer than the curve. Therefore, it's going to be longer than therefore it's going to say 1.02. And moreover, if we read the tags x, y, z, you see essentially x is 0, y is a positive 2, and z is 0. In this case, x is this direction because we're drawing a perpendicular line from the tag to the curve. X is always going to be 0, and the y is this distance 2 feet and 4 inch, something 2 feet and 4 inch, which is roughly over there. And that's how I used to create all these tags. If I were to move this a little bit over, somewhere over here, and run this again. You see that this time, if I open that, this is going to read 0.33. And that's because this intersect over here is about 1/3 along the full length of this curve. So that's how I'm using it to calculate the element location and mapping it to the other curves. And then there are two other concepts to explain. Because we're looking at this view and we see all these projections of the trace, but that's not necessarily the full length of the tray. In fact, if I uncrop the view, you see that there are much longer curves that we didn't see in the previous section. But I'm still getting these tags to align. Why? Because I'm, again, trimmed the projection by the crop view. Therefore, I'm only using this curve, this trimmed curve, as the full length of the tray to calculate essentially the point and parameters along the curve. That's why even though our tray are at different lengths, we're going to maintain that the tag is always visible. Because previously, if I'm going to tag always in the front end of the tray, this one is going to be way beyond the view range. And therefore, the tag will be created away from the view range and become invisible when we first try it. But if we're going to say uncrop the view, do it like that, and now try to say tag it over, I'm going to tag it at the end. Now those things will come to the active location. But if I were to trim this and say do this again, no, element to be tagged. See, like they will all come to over here because they think that's the full length of the view and that's the end of the curve. Another problem is that I want the tag to be aligned regardless of where I draw this curve in what direction. So as you can see, I draw these trays in different direction. One is pointing up, one is pointing down. But when we tag them, naturally, okay, don't need to reset source. Naturally, we want the tag to come to the same location, regardless of the directions I'm drawing them. That's this one. The curve will always follow the view's positive x or positive y. So in this case, even though I'm drawing the trace in this direction first, and in this direction, in those directions, and in those directions. After I took the curves, I'm going to compare it with the views XYZ. Essentially, if the views XYZ exist, it will be something like that. And then I will notice that this curve is following the positive y, so it's good. This view, this curve is not following the positive y, so I'm going to reverse it. This view is in the positive x and y direction, but this curve is not. So I'm going to reverse this curve and make it all pointing towards the positive x and y. In that point, their parameters will all come to the end of the curve and the tag will come aligned. So that's the sequence for when dealing with element that use curve as locations. We're going to determine whether the view is parallel to, the curve is parallel to the view normal, and when it's not, when it is parallel, it projects on the view as a point, which is the same as point element. When the projection on view as a curves, we're going to trim it, use the curves projection as x, and then rotate it if necessary to follow positive view x or positive view y. Finally, the element point will be curve parameter of a certain value, 0.3, 0.9, 1.2, etc., etc. So that's basically all of it in terms of the skeletons of how things should work, the vector between tag and element, how to calculate them, what to do when the element use point, what to do when the element using curve. Right now, this thing works for multi-category tag, element tag, for element using point as locations, or element using curve as locations. So point and curve. I didn't make it to apply to material tags because we rarely use it. And for rooms or spaces and other element that uses essentially surface as locations, again, I rarely need to deal with that. And for example, and in addition to that, space as using a closed curve as locations are even more complicated. So hopefully we don't really run into that many of those cases. And when we do, I'll probably create a special script that applies only to that kind of scenarios, so we don't mess it up with these kind of generic workflows. This is the whole script. Central is warping up. These controls all those pop-up box and workflows, and writing that to a text files, for example, over here. But if we're looking for the whole thing, the essence is this. Extract tag informations, works for point and curve locations, filters the input element, and then create tag and match styles. I'm going to show a little bit on how this works in this kind of view. So for example, if I tag that and turn this to automatic, select that, bring it in, it's going to return these locations, family type, tag type, point for the tag, leaders or not, free or attached, leader end, elbow or not, elbow end, horizontal scale, family type. And then for point-based element is always 0.5 because the curve doesn't come into play. If I were to say remove the leader, it's going to turn that into a false, no leader, therefore no leader end and no elbow end. Leader, free, attached end, it's going to say attached. We're going to do a attached end. I'm going to adjust this a little bit. And here I'm going to select all these elements. Here it comes in a huge amount. And if I bring this in, it's going to filter and return only the chairs. No, only the desks. That's the yes or no for filter by element type. If I turn that to false, now notice how the chair comes in. the other generic model chairs will come in. If I turn that to true, it's going to filter by element type. And finally, with all the input element and the tags information, bring this into the last one. Now it creates all these tags. Well, it is attached end, so it's always going to be a little bit wonky on the leader styles. In most of the cases, I will prefer to do the free end. Therefore, at least most of the case, the leaders will in relatively correct shape. Now, as a bonus for coming all this way, you can see like here is where I try to write them that only works for point, that only works for curves. Combine these, works for both point and curves, and then this one is where it essentially output the value that works for writing that into a txt file. Essentially XYZ has been separated. That's the major difference. As a bonus for staying here on this long, we're going to take a closer look on this. So if you really need, you can use this as a source to try to recreate it. We have a couple defined equations in the front, and then essentially here is querying whether the tag is using a location and if it's using a curve. If it's location, the element z-axis is going to query if it's parallel to view direction, and when it's parallel, it uses a element orientation. When it's not parallel, it's just using the view's orientation. If it is a curve, again, whether the view direction is parallel to the curve direction. And when it's not parallel, we're going to crop these projection curves and using that to find the location and parameters for the adjustments. And finally, we have the locations, calculate the vector between, where is it? This one. It's the vector between the element location and the tag location, and transfer that into these element coordination. Do the same thing for the leader end and elbow. And finally, output this summary that contains all the information that I want. I'm gonna stop here for a little bit on the equations we used down below. And the filter is pretty much simple. All that we need to know is whether it wants to filter by element type. If it's filter by element type, compare the type ID. If it doesn't filter, find if it's a multi-category tag or not. If it's multi-category tag, only filter out view-specific element and also keep detail items. If it is not a multi-category tag, filter only the same category. This is pretty easy. And the create tag and match styles is essentially the reverse engineer equation for this one. It has the same definitions, the same equations, but this time it's going to input a list of elements that is going to be tagged and create tag based on multi-category or not. Gonna go a little bit slower on this. Right. Well, there's a couple things to notice. The tag text will always be horizontal or vertical. Basically, it doesn't rotate. Therefore, for things like here, the leader shape will be impact because the tag text does not rotate. The text length will impact leader shape. The attached leader end will impact leader shape, as we saw there before. When we select the element, the views, elevations, and sections gets in there. And if we uncheck filter by family type, they might get into create tags for the views, but then because those views are not a point-based element nor a curve-based element, the information comes a little wonky. Finally, it doesn't really tag through the group. So you select a group and comes in as a group. It doesn't come in as an element. It doesn't understand what's within that group. So if I was selected what was a model group, it does not know that there is a desk behind it. This is the first time I try to write everything into Python script because obviously looking for the next steps. I want to do the same thing for linked element, and I want to do similar things for text node as well. Not to say that we need to add a text node to every desk in this view, but perhaps in every view behind one desk, we might want to add a text leader to say something that is useful in our case. Say tag all of them, right? For example, this is the information we want to share, and we might create leaders to it, and we might want to do the same thing on multiple views. So I want to be able to copy that as well. But then for text, it's a little bit different because there are multiple leaders, and also because the text, there's other kind of parameters in there. I can do this, and I can create multiple leaders. But then the good thing is, like for text, you can just copy paste them. But stay tuned for the next iteration of this script, and use this as the skeleton for workflows if you need them. And have a nice day. That will be all for today. Thank you all.